So the equation, I'm going to write down, my pen fell. This equation delta P is equal to rho GH doesn't work for gases, okay? You have a different equation for gases, okay? And that is a little bit more complicated. So let's work this one out. So what happens is, if you look at the little picture here, imagine that you have all of these molecules, and because gas is compressible, okay, what happens is that you have all of the weight of the molecules above pressing down on us, okay, and the air around us. And so what happens is that there's a higher pressure down below. So the trend is just the same as in liquids, where you have a higher pressure down below and a lower pressure up above, because you have all of the weight of the stuff above us crushing us down. We have more pressure. Okay, but the difference is that in gases, what happens is the density increases. So the picture over here depicts that the pressure is higher down below, and it's very fluffy, less dense up above. So an important rule is that the pressure is proportional to the density in gases. Well, that's pretty cool observation, okay? So if you double the density, you double the pressure, okay? That's a very important rule, and it's very often forgotten, okay? You forget that relationship. How do pressure and density vary with altitude? Okay, yeah, like I said, it's a much more complicated equation. And this is the formula. Whoa. So this is the formula that's the gas analog of rho GH. So it's not a difference in pressure, it's a ratio of pressure. So for example, I'm going to say, for example, top, bottom, top, bottom, top, bottom, okay? So that's the equation, and let's just see what we have in here. We've got the mass of the molecules, gravity, this is a constant, okay? Temperature, again in Kelvin. We've got this exponential, and we've got a difference in heights, okay? And because pressure is proportional to density, the ratio of the pressures leads to the ratio of the densities. That's what this all this equation is saying. And if you wanted to plot, this is a funny plot over here on the right. If you've plotted the pressure as a function of height, okay, it'll follow a curve like this, where as you go higher and higher up, the pressure becomes lower, okay? So, yeah. Now, very often, we get rid of the exponential by taking the natural log of both sides. So you take the natural log of everything in this equation, and you get the natural log of the pressures ratio is equal to minus mg kBT h minus h naught. So let's see how we're going to use this equation in this next example.